Hi, I'm Gareth Spence and welcome to Tech Talk. If you've read the tech headlines lately, you may have seen that Adtran and euNetworks just launched Quantum Shield, a new service designed to help enterprises move data across Europe in the most secure way possible. To provide details on this, I'm joined by Carl Delaney from euNetworks and Stefan Voll from Adtran. Carl, let's start at the top. What is Quantum Shield?
Quantum Shield fundamentally is a product designed to protect our customer data against decryption from quantum computers. So it's actually a combination of two products that work together. First is advanced line monitoring, which essentially tests for fiber tapping and snooping events. And the second is something called PQC, or post-quantum cryptography, which is a next level encryption technology designed to be quantum resistant. So although both of those products can be bought separately and as standard, actually the combination of the two is kind of an industry first in that it really helps prevent, against store now, decrypt later attacks, which is of course a big concern for enterprises given the likely rise of quantum computing in the future.
Why launch this now? What's driving demand?
Well, quantum computers exist fundamentally. The hardware is there and the hardware is present. So, and that kind of technology will only become more ubiquitous as time goes on. And of course, data will hold inherent value with time. So the store now decrypt data or decrypt attacks are obviously a great concern to enterprises. So we kind of have that element of things. We also have the fact that nefarious actors are getting more and more resourced and more intelligent. So it feels like there's got to be a point in time at which customers have to ask themselves, what could I be doing that I'm not today?
Stefan, where does Adtran fit into this solution?
So the one solution or the one product which we are contributing is transponders with post-quantum cryptography mechanisms on it. Always a pair of transponders is creating a subsystem which is running on its own, which is very easy to operate. So we don't need additional key servers, additional communication. It's all self-sufficient. And the mechanisms on it, the cryptography mechanisms on it are standardized by NIST. So our customers and your customers can be sure that this is up to the highest standards of security. The other element is the line monitoring. That's an always-on OTDR mechanism. And what this allows to do is it allows to actually see snooping, and it allows to locate snooping. So if somebody tries to snoop in, we can see that as an attenuation event, and then we can go after it. So there's also no chance to maybe listen in and try to decrypt that later, because you can see that event.
What's changed from the technology side to make this practical today?
Yeah, so on the LM side, on the OTDR side, those products are very usable today. They are very low cost, so they can be added. And surprisingly enough, not too many people do that, and we are very happy to see that the EU is actually combining that with encryption. It makes a lot of sense. And then the other one is the fact that those PQC mechanisms now are standardized. It's giving our customers the security that those mechanisms are just valid and providing the security we are promising them that they do.
How does this differ from traditional methods of securing data?
It's just this quantum security mechanism. So previously we have had a Diffie-Hellman, which is considered to be safe, but where now we know it's no longer safe forever. Like Google has pushed up their D-Day for decryption day into 2029. This is just 3 years from now. This is not really a lot of time into the future. So they believe that by this point in time, they will be able to decrypt. And if they can decrypt, another, let's say, an actor with funds of a government can decrypt as well. So in 3 years from now, we can decrypt. So we have to react to this threat.
Carl, how important are regulations in shaping a service like this?
Well, I think regulations are really important, right? I think one of the core principles fundamentally is to protect people, to protect the user. And I think they're really helpful in focusing minds, because quite often, people don't know what to ask or they don't understand the challenge. The regulation which dictates that something needs to be put in place by a certain time frame is really helpful. So take kind of NIS2, for example, and it says that the enterprise has to ensure that their IT systems are secure and that they're using the latest technology with which to secure their data. And what latest technology is there other than PQC? So I think it really helps focus the minds of our customers and helps focus the minds of the likes of Adtran and euNetworks to see, well, how can we collaborate to support that customer with the inevitable solution that they need to find.
What are customers actually saying to you when you tell them about this service?
Now, that's a really interesting question because we get a mix. I would say, and it tends to be a little bit of polar opposites. We get some very well-versed CTIOs who know exactly what they want, and some companies even have quantum leads. A lot of the time, we just get customers who are saying, help me understand what this is, help educate me. And I think that's really interesting. And if there's a customer sitting in that camp listening to this interview, I would say, remember the unique thing about encrypting at layer 1, at the wavelength layer, is that all data is encrypted. Because quite often we hear customers saying, hey, I don't really need that because I'm encrypting up the stack somewhere else. Yes, they are part of the data. At layer 1, bits and bytes, we're decrypting all of it. So that's, I think, the key takeaway.
Stefan, what does this service mean for customers more broadly?
It means that they can offer secure services. And the good thing about this regulation we were just talking about is that it's giving a great framework for people to understand what is required and what is enough. So it takes away a lot of uncertainty. It gives them guidance, standardization, and the regulation helps a lot in those discussions. And then they can understand, okay, where do I need it? Where do I not need it? Because they just can find out by reading the regulation. And this is, of course, very helpful.
Final question to both of you. Looking ahead, how do you see the market for quantum-safe connectivity evolving?
I think it's going to become absolutely standard. I mean, as Stefan's already alluded to, we've got a D-Day coming up in allegedly 3 years' time. There's no reason not to believe that. And in any kind of significant event, if there's a post-mortem wash-up, the obvious question for me is, what could you have done differently? Well, if there's a solution that's available on the market, then you should really be thinking about controlling the controllables. So for that reason, it should become standard and people should start thinking about it right now.
We also see a bright future ahead because in the current political climate, all of those security measures are becoming more and more important. Everybody has to prove the networks of every critical infrastructure, everything which is important has to be protected. That's just the way of things. And so people will more and more see the value of that technology. And so I also believe it will become a standard technology over time.
Carl, Stefan, thanks for joining me today.
It's a pleasure.
Thanks a lot.